Alright, here are some basic facts you'll need to know for Monday's quiz. First, the law of electrostatics. Opposite charges attract and like charges repel. So if you have a positive and a negative, they will attract each other. However, if you have a positive or a negative and a negative, they will repel each other. It is also true that an object that is positively or negatively charged, so let's say an object with a net positive charge comes up to an object that has a net neutral charge, the positive or negative object, so this rod here could be positive or negative, can attract the neutral object by polarization, in which all of the negative charges would be attracted to the positives, and then right here you would have a net negative charge that would overall be attracted to the rod. You could also have the same thing happen with a negatively charged object and a neutral object. Here all of the negatives would be repelled by the rod, so they would head to the back of the object. The positives stay where they are, and then that net positive up here gets attracted to the negative object. So something charged can also attract something neutral or something with no net charge. Next up, the charge of an electron is considered the fundamental charge. Also out of this, we might want to talk about that electrons don't move. Electrons do move. Electrons do move, but protons don't move. So if you have an object that has a bunch of positive and negative charges in it, the negatives are free to move around, but the positives must stay where they are. Next up, a fact you need to have memorized. The charge on an electron is 1.6 times 10 to the negative 19th coulombs. You must have that number memorized by tomorrow. Not tomorrow, Tuesday. For an electron, this charge is negative. A proton carries the same charge, so it would have a charge of 1.6 times 10 to the negative 19th coulombs. So if you've got the charge of an electron memorized, remember that it's negative. You'll also then have the charge of a proton, just the positive version of an electron's charge. But again, make sure you have that number memorized by class on Tuesday. Final facts you need to know: electric force is calculated using F equals QE, where Q is the charge and E is the strength of an electric field. E field. E is measured in newtons per coulomb. Charge is measured in coulombs, and force is, of course, as usual, measured in newtons. You know all kinds of fun things with this. Once you've found a force, you can calculate acceleration. You can therefore calculate kinematics. And if you can calculate kinematics, you can calculate kinetic energy, so forth and so on. Field lines point the direction a positive charge will move. Therefore, electrons will move opposite field lines. So if I have a field drawn like so, indicate its direction. If I put a positive charge in that field, it will move in the direction of the field lines. So it will experience a force that way, which will in turn give it a velocity that way. If I put a negative charge in the field, it will experience a force opposite the direction of the field and therefore move in that direction. Now earlier when I said you can do all kinds of neat things once you found a force, by can I mean you will in a free response on the quiz. So, remember how to do free body diagrams, remember how equilibrium works, remember kinematics. I'll use this formula sheet, but it's all going to come up. Forces, kinematics, on the quiz, free response. I'll put up a sample free response question for you to try out, and I'll see you on Tuesday.